This video will be part one of problem 3 from the Heat Calculations Group Problems worksheet. It says in a well-insulated calorimeter, 79 grams of silver originally at 95 degrees Celsius are added to 150 grams of water originally at 21 degrees Celsius. What will be the final temperature of the mixture? All right, so let's make some assumptions here. We're going to put these things together into the same container. Calorimeter is just a device for measuring, used for doing heat experiments, and it's well insulated, so we'll assume that no heat escapes, no heat can get in. So all the heat that's inside the calorimeter will stay inside the calorimeter, no change in the heat. And we're putting hot silver into cold water. So what we should expect then, if we're putting hot silver into cold water, is that the Q that's lost by the silver will be equal to the negative of the Q gained by the water. So this is the silver over here, and this is the water. Okay, but Q is just, as usual, S times M times delta T. So this would be, again, S and M and delta T. And that would be, let's just put parentheses around that, for the silver. I'm going to use S for silver. And then over here would be the negative of S times M times delta T for W for water. But because this is asking us for a specific final temperature, and the interesting thing about the final temperature here will be, because these two things are together in contact with each other, the final temperature of each will be the same. The initial temperatures are different, 95 and 21, but the final temperatures will be the same. All right, so let's do a little bit of expansion here. This will be S, and I'm going to put a little S with that for silver, and the silver's mass, and then this is going to be TF minus Ti for the silver will equal the negative of the specific heat of water, the mass of water, and then TF minus Ti for the water. My next step will be to expand this by distributing the S and the M into the parentheses. So this will be S of the silver, mass of the silver times TF minus S, M, S, and Ti. But here's what I'm going to do. Because the final temperatures are the same, I'm going to leave the F on that. But I'm going to just distribute the S onto the Ti. Instead of Ti, I'm going to say TS, which means the temperature of the silver when it starts. And then over here, I've got negative SW, MW times TF. Again, keeping TF because that's the same for both of them. But now, the negative sign times the negative will make this be plus. Okay, remember, there was a negative to start with, and there's a negative inside. So this is going to be S of the water, mass of the water, temperature. Again, I'm just going to put a W for the water on there. Okay, so we have now distributed the S and the M's, and we have a big, long equation. So we're going to stop for part 1 here, and we're going to do a little bit more algebra manipulation and plug the numbers in and get the answer in part 2.